Hey guys, we are working on Module 5, Lesson 12, and we're going to be looking at some benchmark fractions. Alright, so let me make my slides bigger. There we go. Okay, so we're going to start with a little bit of a review. Let me hide that. Here we go. If we have 6/8, and we're trying to figure out an equivalent fraction that has fourths in the denominator, we're going to divide 6/8 by 2, divide 6/8 by 2 because 8 divided by 2 gives me that 4 in the denominator, and then 6 divided by 2 is 3. Okay, so let's look at this fraction. I've got 2/3 here. All right, and if we drew a tape diagram to look like 2/3, that's what it would look like. There's 2/3. Our one whole is labeled right there. Shade in the 2/3. All right, now let's draw a number line. Okay, so if we drew a number line, it would look like this. The end of the number line, or the 0 point of the number line, would be at the end of the tape diagram. The one whole would be at this end of the tape diagram, and then this would be 1/3 marked directly under this line, 1/3, and then this was our second one shaded in, and 2/3 would be marked directly here. So we mark the lines on our number line at the end of the shaded in section. So 1/3, 2/3 on the number line. All right, so now we're going to look at comparing fractions just by estimating where they would be at on the number line. So here I've got 1/4. Estimating where would that be? Okay, well, I'm going to start by looking at like a half. Okay, so if this is half, then a fourth is like half of a half. So I'm going to say a fourth would be about right here, okay, because it's going to be less than half on that number line. It's going to be down here. Now, 4/5, if I think about this like one whole would be down here on the number line, right? And 4/5, 5/5 would be one whole, right? So 4/5 is only one less, so it would be just right around here on the number line. Okay, and then if I think about 5/8, is 5/8 closer to 0? Is it closer to 1? Or is it closer to the middle? Well, 4/8 is right in the middle because 4 is half of 8, so 4/8 would be right here in the middle. So 5/8 would be like just a little bit over from the middle, like right there. Okay, so if I look at this, I can see exactly what we talked about. So 1/2 is in the middle here. There's my 0. There's my 1. 1/4 is kind of right halfway between the 1/2 and the 0. Okay. And then 5/8, if I think about 5/8 as an equivalent to a half, so 4/8 would be the half. So 5/8 is going to be just a little bit bigger than that. And then if I think about my one whole as fifths, 5/5 would be my one whole, so 4/5 is going to be just one less than 5/5. So it's just estimating. We're not doing exact right now. All right, so now we're going to be looking at 6. Okay, how many total 6 would there be in a whole? Well, we would have 1 6, 2 6, 3 6, 4 6, 5 6, and 6 6. When we get to 6 6, oops, that's not what I wanted. When we get to 6 6, that is equivalent to one whole. Okay, so how many 6 would there be in a half? Well, 1 6, 2 6, 3 6. Okay, right here. 3 6 would be a half, okay? And then 2 6 or 3 6. I'm going to go to my Jamboard here. All right, so let me draw for you. All right, so let's talk about this. We've got 6, okay? Here's my 6. We know 6 6 would be down here at one whole, right? Because whenever the numerator and the denominator are the same, that's equivalent to a whole. And down here we have 0. Okay, so right in the middle at a half, if we're thinking about a half of 6 would be 3. So 3 6 would be there. Okay, so it said to plot 2 6. So if we plotted 2 6, we're going to look. There's 0. We would have to have 1 2. So 2 6 would be right about here. Does that make sense? All right, and then it said to look at 2/6, and is 2/6 less than a half? Well, if we think about 3/6 as our 1/2 point, right, because 1/2 and 3/6 are equivalent, then 2/6 is less than 1/2. Now, I want to remind you of what you learned last year with the butterfly method, because I know you all know the butterfly method from last year. But we're going to remind you, if I've got 2/6 and I've got 3/6, and I'm trying to figure out which one of these is greater. Okay, if I multiply my denominator and my numerator, 6 times 2 is 12. And then I multiply my denominator and my numerator. 6 times 3 is 18. Okay, 12 is definitely smaller, so 2/6 is smaller than 3/6. 3/6 has the 18 over there. And 18 is bigger than 12, so 3/6 is bigger than 2/6. Okay, let's go back here. And we're going to go here, and I'm going to present. Okay, so now we're going to be looking at 6. Okay, so here are my 6ths on a number line, and here's my 1/2, right? And so when we write that, we would say 2/6 is less than 1/2. We said 2/6 is less than 3/6, but it's also less than 1/2. Okay, so now let's look at this. We've got 2/3. Is 2/3 greater than 1/2 or less than 1/2? Well, all right, 2/3, if we think about it, let's go back over here to my Jamboard. And we're going to split. So this is my 1 whole, my 0, 1/3, and 2/3. Okay, and so if we think about where 1/2 would fall on this line, well, 1/2 is going to be right in the middle, and this is 1/2 on the number line. So if we look at this, 2/3 is definitely the larger fraction. It's closer to 1. Okay, and if we also look at this like we did the butterfly, if I have 1/2 and I have 2/3, 1 times 3 is 3, 2 times 2 is 4. 4 is definitely bigger than 3, so 2/3 is bigger than 1/2. We can see it in the picture of the number line, and we can see it when we do our butterfly method there. Oh. Okay, reload. All right. Sorry. Not sure why that just happened. We're going to go here. Okay. All right, so we did that. 1/2 is between 1/3 and 2/3, so 2/3 is greater. 1/3 is less than 1/2. 2/3 is greater than 1/2. Okay. All right, so let's look at 2/5. Is 2/5 greater than 1/2 or less than 1/2? Well, what's half of 5? You can't split 5 equally, so it'd be like 2 1/2 is half of 5. If we think about it as, let's think about it in a picture. So half is halfway between 2/5 and 3/5. So 2/5 is less than 1/2. All right, let's draw it. Okay. So here we are. And I've got 0, and I've got 1, and I've got 1, 2, 3, 4 fifths. Let's see, 1/5, 2 fifths, 3 fifths, 4 fifths. And then I'll look at where 1/2 would fall. And 1/2 is going to be right in the center of this line. 1/2 is going to be right here, right in the center of 2/5 and 3/5. That's what that was just saying. Okay, so if I'm comparing 2/5 and 1/2 here, 2/5 is smaller, lower down on my number line than my 1/2. And if I do my butterfly method, okay, So 2 times 2 is 4. 1 times 5 is 5. 5 is definitely bigger, so 1/2 is bigger than 2/5. Alright. Alrighty. Alright, so let's put it on a number line, which we just did. So we've got 1/2 here, and we've got 2/5 here, and it's on the number line, ready to go. Now, if we wanted to make it where 2/5 had a common denominator with 1/2, okay, then we would need to make tenths. Okay, so let me go back to my Jamboard, and we're going to go back here. Okay, so see how I had to split my fifths in half in order to get my 1/2 in there? I'm going to make my 1/2 a different color. I'm going to make it green, just so it's a different color. Okay, now, if I split every one of my fifths in half, just like I did that fifth, if I split every one of my fifths in half, then what I have is I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. Okay, so I've got to count them, and I've got 10 pieces, so this would be 1/10, and then 5/5 would be 2/10. We don't skip over that fifth. Okay, so 2/10 and 1/5 are equal, they're equivalent. Then I've got 3/10, then I've got 4/10, so 2/5 and 4/10 are equal. Then I've got 5/10, which makes sense because 5 is half of 10. 6/10, so I've got 6/10 and 3/5. 7/10, 8/10, 9/10, and then 1/2 would be 10/10. So what we did is we found a common denominator. Okay, so when we look at our denominators of 5 and 2, okay, the common denominator between 5 and 2 means we multiply the 5 times the 2 to make 10. And so then we put that underneath. In third grade, I know you only did the top number, but now we're finding a common denominator, so 5 times 2 is 10. So 2/5 is equal to 4/10, and 1/2 is equal to 5/10. So when we look at 4/10 and 5/10, it's really easy to see that 5/10 is bigger. So when you are doing the butterfly, what you're really doing is you're finding a common denominator. Okay. All right. So what do we know about 5/12 in relation to 0, 1, and 1/2? Well, if I think about what is half of 12, half of 12 is 6. Okay, so if I go back here to my Jamboard and I draw my number line, and we want to figure out the halfway point right here, and we know we're looking at 12ths, okay? So half of 12 is 6, right? So that's going to be, this is going to be our halfway mark, because half of 12 is 6, and so 5/12, even if I don't draw it all the way out, we know 5/12 is going to be less than 6/12, right? So let's see. 1, 2, 3. 1, 2, 3, 4. Okay, so 5/12 would be like there, because this would be 1/12, 2, 12, 3. Oh, we missed a 4. I made fifths. Let's try again. There we go. Now we're at 5/12. Switch this to a pen. 2/12 and, oh, sorry, that doesn't look like a 12th, but, and 1/12. Okay. Phew. All right, let's look at this. Okay, so 5/12 is greater than 0, but it's less than 1. 5/12 is almost halfway, but it's a little less than halfway because 6/12 would be half. So 5/12 is going to be less than 6/12. Okay, 5/12 on a number line. We just did that. It's going to be a little before 1/2. Okay. 7/8 in relation to 0, 1/2, and 1. Well, 8/8 is 1 whole, so 7/8 is just a little less than that, so it's going to be closer to 1, because 4/8 would be 1/2, because half of 8 is 4. So it's going to be closer to 1. There it is on the number line. 7/8, so 8/8 would be 1 whole, so 7/8 is a little less than 1. All right, here's what we're going to do. We are going to go to our problem set. All right, and I know that's not perfect, but there we go, that's better. Okay, so we're going to try to put these on the number line, just kind of based on what fraction they are. So 1/3. So we know, okay, 1/2 is here. If I take my fingers and I try to kind of make equal 3 parts, and I'm just estimating, but 1/3 is going to be about right there. Okay, so now 5/6. Okay, well 6/6, right? 6/6 would be 1 whole, right? I know 6/6 would be 1 whole. So 5/6 is going to be a little less than 1 whole. And again, I'm not trying to make this perfect. I'm just trying to estimate. So 5/6 is going to be closer to the 1 whole than it's going to be to the half. Going to be closer down this way. All right, 7/12. Okay, well that's not close to 0. What would half of 12 be? Well, half of 12 would be 6/12, right? So 7/12 is like a little bit more than 6/12. So 7/12 is going to be closest to 1/2. So this one's going to be closest to 1/2, the 7/12. The 5/6 is going to be closest to 1 whole, and the 1/3 is going to be I think it's closer to 1/2 than it's going to be to 0. It's going to be closer to 1/2 than it is to 0. Okay, so 7/12 is bigger than a half, because see, 6/12 is the half, 7/12 is 1 more. So 7/12 is going to be bigger than a half. And the way I did that is because I kind of changed this 1/2 into 12. Well, how did I get to 12? Times 6 times 6. Okay, remember this is all what we just did. So 1/2 is equal to 6/12. So 7/12 is actually the bigger. Okay, so 5/6, let's make this into 12ths. We'll make our 6th into 12ths. So to do that, it's times 2 times 2, so this would be 10/12ths, and 10/12ths is definitely bigger than 7/12ths. Do you see how making it into equivalent fractions helps us see which one is bigger, and it also kind of helps us figure out where they go up here on the number line. All right, so let's try that with this one. All right, so 11/12ths. Well, 12/12ths would be 1 whole, so 11/12ths would be 1 less than 12/12ths. So it's going to be down here close to 1 whole, but not quite. All right, 1/4. Well, I know 1/4 is, so I know 2/2 is 2/4, and this is going to be 0/4 at 0. So 1/4 is going to be right in between the 0 and the 1/2. 1/4 would be right in the middle. Okay, and then 3/8. All right, so let's think about this. So 1/2 could also be 4/8, right? 1/2 could be 4/8. So 3/8 is actually going to be in the middle of 1/4 and 1/2, because If I took 1/4 and I made it into eighths, this would be 2/8, because to get from 4 to 8 is times 2, and 1 times 2 is 2. So 1/4 is equivalent to 2/8. So 3/8 would be right in the middle of 1/4 and 1/2. Okay, so select two fractions and compare them. So 3/8, let's compare that to 1/4. Okay, so there's 1/4 and there's 3/8. 3/8 is greater than 1/4. Okay, well, let's try 1/4 and 11/12. So 1/4 and 11/12. Well, 1/4 is way down here. 11/12 is way down here. 11/12 is definitely bigger. Okay. All right, so now we're going to just compare these fractions by thinking about where they are in between 0, 1, and 2. And we're also going to kind of think about equivalent fractions like we were just doing. All right, so if I have 1/2 and 3/4, all right, this half, I'm going to think about that as fourths. So how do I get from 2 to 4? Well, it's times 2. So 1 times 2 is 2. So 1/2 is equivalent to 2/4, and 2/4 is smaller than 3/4. All right, so let's think about this one. 1/2 and 7/8. Well, what would 1/2 be in eighths? Okay, well, 2 times 4 is 8, and 1 times 4 is 4. So we've got 4/8. So 7/8 is definitely bigger. 3 and 5, I can't really do. I can't really make an equivalent fraction for these. But let's just think about this. 2/3. So if I think about where 1/2 is, 0, 1, and 1/2. Okay, 2/3 is going to be bigger than 1/2, because if I had thirds, my thirds are going to be like this, and this would be 2/3. So it's going to be bigger than 1/2. And 2/5, if I'm thinking about my fifths, is going to be a little less than 1/2. So 2/3 is going to be the bigger fraction. Now, if this number line confuses you, again, just do the butterfly method. 2 times 5 is 10. 3 times 2 is 6. Okay, then we come down here, and 3 times 5 is 15. 15 is our common denominator, so I've got 6/15 and 10/15, and 10/15 is definitely bigger. Definitely bigger. Okay, so if the number line is confusing you, use the butterfly method. Okay, let's look at this one. I've got fifths and I've got tenths. Well, I can definitely take these fifths and I can make them into tenths, because 5 times 2 is 10. So 3 times 2 is going to be 6. And 6/10 is definitely smaller than 9/10. So that one was kind of easy, because we could make it. This one does not have a denominator where we can find an equivalent fraction easily. So for this one, I'm going to do the butterfly. 2 times 8 is 16. 3 times 7 is 21. Okay, and then 3 times 8 is 24, right? So this is 16 24ths, 21 24ths. And if I think about these two fractions on the number line, okay, and I think about 7/8. 7/8 is going to be down here closer to 1, because 8/8 is going to be 1 whole. And then I think about 2/3. 2/3 is going to be bigger than 1/2, but it's not going to be quite down there as far as 7/8. So 7/8 is definitely the bigger fraction. Okay, I'm going to leave a few of these for us to try in class. Make sure if you have any questions, you ask during the lesson. Thanks, guys.